Hello students, welcome back. Today we'll study dimensional formula of certain physical quantities. Till our last videos, you had already studied about the dimensional formula, its benefits of it, limitation. Okay, so now today we'll derive dimensional formula of some physical quantities. So let's start with the first one. Density rho is equal to mass by volume. So see, whenever it is written in square bracket, that means this is the dimensional formula. So this will be equal to, let me derive it in rough, dimensional formula. This will be equal to dimensional formula of mass, dimensional formula of volume. See, density equal to mass by volume. So dimensional formula of density will be equal to dimensional formula of mass upon dimensional formula of volume. What is dimensional formula for mass? M1. Clear? What is dimensional formula for volume? Volume means L cube. So L3. Clear? So this will be equal to M1. When this goes in the numerator, it will be L minus 3. So the dimensional formula for density will be equal to M1 L minus 3 T 0, as there is no time factor, so I will consider as T 0. So this is the dimensional formula for density. Okay, now let's move to the next one. That is speed or velocity, right? So we need to find out the dimension formula for velocity. Remember, this is small v, the symbol for velocity is small v, not capital V. Capital V is for volume. So what is the formula for velocity? Distance upon time. So dimensional formula for velocity will be equal to dimensional formula for distance upon dimensional formula for time. So this will be equal to, what is the dimensional formula for distance? Distance means length. So this is L. And as it is only one time, it's 1. Upon, for time, it's T1. So L1, when this goes in the numerator, T minus 1. As there is no quantity such as mass, we are not writing about the mass. So M0. So this will be equal to M0 L1 T minus 1. Okay. So remember velocity, when you require the dimensional formula for velocity, L1 T minus 1. Clear? Let's move to the next one. Acceleration A, that is equal to velocity by time. So dimensional formula for acceleration, dimensional formula for velocity upon dimensional formula for time. What is the dimensional formula for velocity? L1 t minus 1, as m raised to 0. I'm not considering here. Okay, if you forgot the velocity, dimensional form of velocity, then derive it using this d by t, this equation. Upon, for time, it's t1. So when this time goes in numerator, L1, see these both are same base quantity. So it's minus 1. When this goes in numerator, it's plus 1 here. It will be minus 1, right? Because in both the case, the base quantity are same. So it's L1 T minus 2. So the dimensional formula for acceleration, this is equal to, again there is no mass factor. So M0 L1 T minus 2. Clear? Let's move to the next one. Momentum. Momentum, the formula for momentum is mass into velocity. You will study this quantity in the later chapters, right? So at present, we only want to deal with the dimensional formula. So just use the formula for momentum P equal to mv. Small p is the symbol for momentum. So the dimensional formula, this is equal to dimensional formula for mass and dimensional formula for velocity. So what is dimensional formula for mass? m1. For velocity, L1t minus 1. Again, I'm not writing here this mass. So directly go to the dimensional formula for momentum. It's small p. That is equal to m1 L1 t minus 1. Okay? Force. The next one is force. You already know the formula for force. F equal to ma. Force is equal to mass into acceleration. So dimensional formula for force, that is equal to dimensional formula for mass into dimensional formula for acceleration. Dimensional formula for mass m1. For acceleration it's L1t minus 2. Okay, so I got the dimensional formula for force. This is m1 L1 t minus 2. This is very important. Means you will be using this frequently, right? So you have to remember this formula. Okay, now don't go to derive it every time when you require the dimensional formula for force. For other quantities like momentum, you can derive it. This will be not used as frequently as you will be using the dimensional formula for force. There is also another one, energy. So at present, you have to remember. So whenever you require to write down the dimensional formula for force, it's m1 L1 t minus 2. Remember this, okay? So this was about the dimensional formula of these five quantities: density, speed or velocity, acceleration, momentum, force. Okay. See, the dimensional formula for speed and velocity both are same. Right? The only difference here is one is a scalar quantity, another is a vector quantity. The formula for both is same. Right? So just note down the dimensional formula of these five physical quantities. The next is work. Formula for work done is equal to force into displacement. So dimension formula for work, this is equal to dimension formula of force into dimension formula of displacement. What is the dimension formula for force? That is m1 L1 t minus 2. And for displacement, that is distance, sorry, it's L1. So it is that. So this will be equal to m1L, 1 plus 1, 2, t minus 2. So dimension formula for work will be equal to m1 L2 t minus 2. This is also very important dimensional formula. So whenever you require the dimensional formula for work, don't derive it, just remember it, it's m1 L2 t minus 2. For force, m1 L1 t minus 2. For work, m1 L2 t minus 2. The next is energy, right? Now see, we take any form of energy. The dimensional formula of energy is same, just like when we take volume. The dimensional formula for volume is L3. Whether it is a volume of a cube, volume of a cuboid, volume of a sphere, whatever it is, it's always L cube. So we can take any form of energy. Potential energy, kinetic energy, heat energy, whichever energy you take, its dimensional formula is same. So I just took a simple formula about kinetic energy. Here I have taken kinetic energy. So what is the dimension formula? You can also take here potential energy like mgh. You can also use that formula. Clear? So here kinetic energy, half, that is a number that don't have dimensions. So mass and V square. So V square, it's this way. So what is the dimension formula for mass? M1. What is the dimension formula for velocity? Distance by time, length upon time, L1 t minus 1. And as it was V square, it's 2. So M1 L2 T minus 2. Same as work done. So dimension formula for energy, this is also equal to M1 L2 T minus 2. This is also very important. So remember dimension formula for force M1 L1 T minus 2, for work and energy M1 L2 T minus 2. You can also use the formula for potential energy mgh. Then also the dimension formula would be same. Okay. Now let's move to the next one. Power. Power is equal to work done per unit time. So dimension formula for power. Remember it's capital P. Even the symbol of pressure is capital P. So for power here in this case it's power. What is that? Work done per unit time. What is the dimension formula for work done? M1 L2 T minus 2. So it's M1 L2 T minus 2 upon, for time it's T. So T1. So this will be M1 L2 minus 2 minus 1 minus 3. It's plus here, but when it goes to numerator, it's minus 3. So dimension formula for power, it's M1 L2 T minus 3, right? So if you remember the formula for work, you can easily derive it. Work by time. Clear? The next, pressure. Pressure, what is pressure? Force acting per unit area, that is pressure. So dimension formula here, P is for pressure. Dimension formula for force upon dimensional formula for area. So what is dimension formula for force? M1 L1 T minus 2. I'm writing it directly. If you forget it, then you have to derive it by mass into acceleration and then add it. Okay, but I prefer you must remember it. Area means length into length, L square. So M1 L 1 minus 2, it's minus 1 T minus 2. So the dimensional formula for pressure, this is equal to M1 L minus 1 T minus 2. Clear? The next is frequency. Frequency means how much frequently it is repeating. So frequency is 1 by capital D, that means 1 upon periodic time. So the dimension formula for frequency will be 1 upon dimension formula of T. So 1 upon T time. So dimension formula of time is T1. So this will be T minus 1. So the dimensional formula for frequency, as there is no factor such as mass and length, m0 0 t minus 1. Clear? So this was about frequency. So these are the dimensional formula for work and energy, same m1 l2 t minus 2. Okay, power m1 l2 t minus 3, pressure m1 l minus 1 t minus 2, and frequency m0 l0 t minus 1. Remember, you don't have to learn all this dimensional formula, right? But the important thing is you must know the formulas. This you have to remember because this will be useful even in the later chapters. So if you remember this, you can easily derive the dimension formula. And in between, there are some important dimension formulas like for the force, work, energy. You have to learn that. Yeah. So at present, note down these five quantities dimensional formula. Okay, students, so that's it for today. There are even many more physical quantities that you will be studying in the later chapters. Once you get the formula for that physical quantity, you can easily derive its dimensional formula. Okay, so that we will study in the later chapters. At present, that's it for today. Thank you.